So, dear students, am I audible to you?
Yes, ma'am.
Okay. So, let's begin our session. So, can you see my slide?
Yes, ma'am.
Okay. All right. So, today we are going to study about structural analysis. So, in this structural analysis, we are going to see the support reactions. What are the different types of support reaction? And what are the different types of structures, determinant and indeterminate structures? Then estimation of structures, how to estimate that whether the structure is determinant or indeterminate structure. And we will see some of the couple of problems, the different types of problems that they ask in your gate examination from this particular topic. Okay. Now, first we will go and see the different types of support reaction. Now, this is very important. Now, in your exam or in your exam point of view, you have to analyze the different types of support reactions will be there and displacement or different types of reaction forces that will be acting on the different types of support. Okay, so basically there are of 5 types. Okay, first is a roller type, second one is a hinge type, third one is your support on inclined plane, fourth one is a fixed type, and fifth one is a hinge type. Okay, so the roller, right? So first, before starting with this, so this is very very important. I request all of you, first you note down this tabular column. Okay, I'm giving you 1 minute time, so I request all of you to note down this. Once you're done, just let me know that you have done with this thing. Are you done with this noting down process?
No, ma'am.
Please note down it. This is very important. You need to identify the type of support. Okay, so once you know the type of support, then only you can proceed forward. So in your exam paper, they can give you the different kind of rollers and different kind of schematical or graphical representation. Okay, so by seeing the figure, you need to understand the type of rolling or the support they are asking. Okay, so this is a very very important fact. Now, second is, first is a roller. So in this roller, you can see what are the different kind of schematic diagram. Now you should know the what kind of displacement should be there. Okay, displacement. Now before coming to displacement, you should know what are the support reaction. So whenever you have the roller, that means whenever you have some kind of two circular kind of thing, right? That means this can move along this horizontal direction. This particular beam or whatever the support agent you have, it has a capability to move along this. The same kind of roller you can also find in this way. Okay, you can also find in this way, this pattern, right? Now in this case, what will happen? Now this particular this is a fixed, this shows this schematic, that the hatched line that you can see, it shows or represent that it is a fixed surface. Along this fixed surface, this can move along this direction. It can move along this direction. Now you have to see and analyze that thing. Now it is placed on an horizontal surface. So in this horizontal surface, when it is placed, that means along the y direction, this is a y direction and this is a x direction. Okay, so y direction there will be no displacement, but there will be some displacement along the x direction. And in this case, there will be a vertical force that will be acting over here. Okay, so in this kind of when the roller is placed horizontally. Now here in this case, it may act like this. So based on the different location, either it is placed horizontally or vertically, you should understand this concept. Accordingly, it will react. Okay, but the graphical representation is very, very important. So here the number of support reaction is 1. Okay, coming to the next is a hinged. Okay, in case of hinged, what happens? There will be no displacement either in the x direction nor in the y direction. There won't be any displacement. So it will be completely hinge on both the x and y plane. So in this case, what will happen? So you will have a two support reaction. One is a vertical. In some of the textbook, you can find they are denoted by f suffix x, or they are denoted by vertical as v or f suffix v. You can represent in various kind of notations. Okay, but the main concept is hinge. When it is hinged, that means it will have a two support reaction. Since it is having two support reaction, there will be no displacement either in the x direction nor in the y direction. So it will be like this. Either it can represent the horizontal one h or f suffix y. Sorry, this is f suffix y, this is f suffix x. Because along the x direction, this is vertical along the y direction, or it is also known as f suffix h. Okay, there are lot many notations are can be represented. Okay, next is supported on an inclined plane. So whenever there is a supported on the inclined plane, that means the plane has been transformed from the xy to an t and n plane. Okay, so in these cases, whatever the loads will be acted, right, perpendicularly, and it will be resolved. It has to be or need to be resolved whatever the plane it has been transformed. Okay, same along the t plane and along the n plane, the new plane which has been transformed or whatever the angle it is. So there the displacement will be 0. Okay. Apart from that, any other axis, that is if you transform to another plane of x and y, it will not be 0, but it will be 0 on the particular plane or the action of force. Fourth one is fixed. So whenever it is fixed, that is, you can see this representation. So what will happen here? The displacement will take place in both vertical, horizontal and rotational, because here we will have the three forces. Support reactions will be taking. One is a vertical, one is a horizontal, okay, horizontal H, another is a moment. Another is a moment. So whenever you see there is a fixed surface or fixed support reactions, there it will have the three support reactions. Okay, sometimes for 1 mark question also they ask this kind of questions. Okay, what will be the number of displacement, where in which direction the displacement is going to be 0 on this kind of support reaction. So you can expect such kind of questions from here, and this is a very, very fundamental thing. Now in this fundamental also, you need to use this concept to solve the problem. Okay, so we will have, as I've said, that there are different kind of structures. To identify the nature or the degree of freedom of a structure, you need to know this support reactions. Okay, now in case of hinge, now hinge is sometimes when you can see this kind of representation. Now there is a difference of two different hinge, right? In between the beams, if there is a dot or there is a circle, something like that. Okay, so on that hinge means there will be some kind of movements that will be acted. Okay, in that there are some rotations, that means some kind of movement will be acting. Now, based on the graphical representation, you have to see. Now, this is the last point which you can see. It is in between the two beams or two frames. We will see how this beam, frames, and trusses are different with each other and how they react. Okay. Shall I move to next? Please let me know. Play.
Yes, ma'am.
Okay. Yeah. Now starting with the trusses. Okay. Now what it defines the trusses. Now the plain truss is a system made up of several interconnected bars at an articulated joints. That means there are of several members. Here one member, this is one member. There are a lot many members and they are connected. These connecting points are called as a nodes or joints. Some of the textbook you can find they have declared as a nodes. Joints. Nodes are nothing but the joints when two members are connected with each other, right? So either this trusses can be of this complete the connection of many small members, and they have joined together and make a big entire frame of structures. So that particular structure can undergo several members that they can undergo either by tension or the compression. Okay, it is they have not declared that it will be undergoing only tension or only compression, right? But it can be of combination of both, right? But if there are some conditions, a bar or the trusses that is only subjected to compression, there are certain trusses which any members that if it only undergo compression, okay, such kind of structures is known as a plane. Okay, when any structures which will undergo only compression, just like a cumulative number of struts. Okay, so previous class I have discussed what is struts, right? A member which undergo only compression, there is a difference between struts and tie where only a member where only tension, a beam or a member can only undergo tension, so that particular member is called as a tie. And stud where only compression. And what is this truss? Truss is a combination of the tie and the strut. Okay, but if any truss which only having the combination of struts alone, then it can also be named as a plane. Okay. So sometimes they might use some kind of terminology, so you must understand the facts. Or this time they are asking you the multiple choice questions like selection questions. So you need to know the definition quite well. Okay. Right. Coming to the beam. Now beam is a rectilinear structure element. Okay. Now can you tell me what is mean by the word called rectilinear structure? What is that defined? Even whenever you're studying, you should learn the what kind of words they're using, because in your gate examination, in your general aptitude section, they might use the same kind of words in your general aptitude. So whenever you learn any vocabulary, learn clearly about it. Okay, so that might be beneficial in your general aptitude. Now, what does that mean or understanding by the rectilinear structure element? Before we have studied beams and what that defines rectilinear structural elements. Anyone? Can anybody say about it?
Ma'am, when studied about rectilinear motion, then it's a motion in a straight line. I know that.
Exactly, something linear. Okay, and whatever the combination of members, that should be uniform and that should be straight. Very good. So this is one of the vocabulary that you can take away from this session also. Okay, a beam is always has to be a very straight, okay, rectilinear structural element. And what it does, this whenever the load is applied to any entire this beam, it should act perpendicular to the middle axis. This is also one of the very important. That means if I draw a cross section of whatever the beam, right, it should act in the middle of it. If the cross section of this beam is rectangular, it should lie on the same plane, same geometric plane, as well as perpendicular to the middle axis. Okay. Now, in this type of structure, the applied load should be bending and shearing force. So, whenever there is a beam, we should understand it should. This kind of question can also be asked. Again, I'm telling you. So, bending can undergo only the bending and the shearing force. Okay, the normal force will be ignored. Here, the normal force will be ignored. Please make a note of it, because in upcoming points we will see where the normal force will also be included. Okay, but in case of beam, it is the normal force is neglected, right? Moving to the next, we'll see frames. Now, frames is a combination of several rectilinear or oblique materials connected by rigid joints. Now, this is also one of the takeaway points, connected by the rigid points. Now, you should know the difference between the frames and the beams. Okay, beams were only a rectilinear members, but here in case of frames, it can be the combination of several rectilinear and oblique frames. Oblique means it can be any members can be inclinedly connected. Okay, inclinedly connected. Okay, oblique element, and it can be of several types, several members that can be joined rigidly, right? And here in this frames, what are the loads that will be acting? Bending, shear forces, and the normal forces due to external loading system. Okay, so here in case of frames, normal force is included. Okay, and excluded where? In case of beams. So you should know the difference. Always remember the differences. Okay, in gate question, their main motto, the main concept is to make them confuse, to make you confuse. Okay, so whatever the possibility they get, they will try to confuse you, but be strict to the points. These are the highlighting points. All right. Right. Now we have a different kind of beams called as a cross beams. Okay. Now here it is a slight difference in the cross beams. What happens? It is a combination of rectilinear elements arranged in the same plane, consisting a series of beams. That means already we have seen a beam. What is a beam defined? It is a rectilinear structural element, and we will have a combination of that. Either it can be in series, either it will be in see, if I'm joining two or three or more series, it is coming parallel with each other. Now this combination, as you can see in this figure, is called as a cross beams. Okay, these are the cross beams, and these are the engrossed by bending, shear force, normal forces, and the torsion. Torsion is an additional one. Now we have seen bending and shear forces only for the beam, right? Then we have seen frames. Frames consist of bending, shear, and normal forces. In case of cross beam, we have the combination of it, bending, shear, normal forces, as well as a torsion. Okay, so as well as a torsion, right? So whenever there is a torsion, that means there will be some kind of twisting force, right? Now you can see some of the examples where they use in the auditoriums, sports halls, the heavy large slabs, right? So these are the following examples of this cross beams, right? Okay. Now coming to an arch. So arches, you can see what you can see most of the sometimes in bridges. You can see such kind of even some of the domes, some sports halls, some of the stores. You can see this kind of arch thing. Even some in your home construction also you can see some of the churches. You can see this arch thing. Okay, now what it is, it is an inverted curve structures. Okay, now what are the forces that it applies? It applies a normal force, shear force, and the bending force. These are the following forces, as you can say, same as what we have seen in the frames. So they can ask you this question also: what are the following structural elements will undergo the normal force, shear force, and bending force, right? So you might have the options like separate options like bending, beam, truss, frame, arch, cross beams. So you have to select among that the arches and the frames, which undergoes the shear, normal, as well as bending moments. Right. Now coming to the classifications of the structures. This is very, very important. Now we are entering into the core thing, the different types of structures. Okay. Basically, we have two different structures: statically determinate structures and statically indeterminate structure. And how we differentiate that. Okay. Now in this particular topic they ask you whether to predict whether the particular structure whatever they have given is statically determinate or indeterminate structure or not. Okay, now we should know what is statically determinate. Now whenever there is we can satisfy this equations, that is summation of horizontal forces, okay, should be equal to 0, then summation of all the vertical forces and the moment. Now using these three equations, when we able to find out the support reaction of that particular structures, or either by bending moments, shear force, or normal forces, then that particular structure we can classify that is the determinate structure. Okay. Now it is always asked that what are the following structures are consist of the determinant structures. So you should know that also: simply supported beam, cantilever beam, single and double hanged beam, three hinge arches. Right? So these are the following things that comes under the uh, statically determinant structures. Now please let me know, am I audible to all of you, to ensure that I'm
Yes,
audible?
ma'am.
All right, fine, fine. So, right. So, we'll move to next. What it defines a statically indeterminate structure. Now, statically indeterminate structure represents when this particular three formulas, using this also we are unable to find out the number of support reactions. Okay, now already I've discussed what is mean by the support reactions, right? So either there is maybe some kind of beams, for an example, like we have one beam, like this is one structure, here we have another, this is a hinged, this is the roller, right? We have another some kind of structure here, right? Here some amount of load is acting and this is a structure. Now maybe for an example using this, now This is a, just let me change the ink color. Now here what will be, this is a point A, this is a point B, this is a C and D point. The D point maybe, for an example, 6 kilonewton is applied. Okay, 6 kilonewton is applied. Now here what are the different forces? Here one force, here one force will act. Now here only vertically upwards, here also vertically upwards, here one forces, right? Now we have, what is the number of support? 1, 2, 3, 4, 5, 6. 6 supports, and we have to find out the 6 support reactions using only this formula. Now you're unable to find out sub one of the support reactions. Then we need to consider that but this particular structure is an indeterminate structure. Now there are a lot many different ways to estimate or to predict the indeterminate structures. So we will come in the later part also, right? So this is the difference between the statically determinate and indeterminate structure. Okay. Now here there are a lot many ways to find out the degree of statically indeterminate structure. That also we will come in an upcoming slides. Now, uh, this is very important to know. The redundant or the indeterminate structures are not capable of analyze by means of basic equilibrium equation. Now, this is called as a basic equilibrium equation. So, it cannot be find out using this. Now for that, what kind of thing we can use? There are some special methods. So please note down the methods. The methods we will have a separate session for that. We will have our external faculty will be coming for especially taking care of this particular topic. Okay, who is specialist in these things. So today I'm not going to cover this special methods, right? So I'm just highlighting these are the methods can be used to find out the indeterminate structure. Okay, the strain energy method, slope deflection method, then moment distribution method, right? The virtual work done method, matrix method. Matrix method is not that required in your exam, in your gate exam or the competitive exam point of view, but the strain energy method, deflection method, and moment distribution method are very much important. Okay, so that the external faculty will be taking care. Now, these are the methods that which will help to find out. Now, what are the beams that are indeterminate structure? First of all, it's a fixed beam, continuous beam, fixed arches, two hinge arches, right? Then multi-stored frames. So these are comes under the indeterminate structure. So whenever you see any structure which is a fixed or continuous beam, right? So mostly they ask fixed and continuous beam. So you have to determine that it has to proceed with an indeterminate process. Okay, so special methods need to be implemented. Okay, so if you are getting simply supported or cantilever beam or any other simple beams, then you can simply proceed with this kind of formulas where we will use the all the statically equilibrium equations that can be done using it. Okay, now, there are some of the differences that you should know the difference between the determinant and indeterminate structures. So, they might ask the questions from here also. So, first of all, determinant structure which will satisfy all the equilibrium conditions. Now, equilibrium condition is nothing but summation of f of x equal to 0, that is a summation of horizontal forces, summation of vertical forces, and the summation of all the moments equal to 0. But here, in this case of indeterminate structure, it will not satisfy that. Next important point is the bending moment or the shear force at any section is independent of the material property. Okay, independent of the material property here. That means here material property, I can say that fractional rigidity, okay, which is a combination of Young's modulus and the moment of inertia, or I can say Young's modulus also, right? But here in this case, indeterminate structure, which is a dependent factor, the material property, that means there will be some consideration of EI, okay, EI or combination of that. Next point. Now, coming to the same thing, the bending moment or the shear forces at any section is independent of the cross section or the moment of inertia, right? As I've discussed before, that EI, in short, I can say the fractional rigidity will be independent in the determinant structure and will be dependent on the indeterminate structure. Okay, the same opposite will happen over here. So here in this indeterminate structure, it is dependent on the cross section of the section, whether it is I, what is the dimension of it. Okay, next important point is the temperature variation does not cause any stresses. So here both the temperature as well as the self weight will be ignored. Okay, temperature and the self weight, that whatever the variation of the inbuilt structure will be ignored over here. But here also self weight will be ignored, but the temperature variation might be included. It depends on the problem statement. It might include in the indeterminate structure. Right. Now fifth is a no stresses are caused due to lack of fit. Okay, no stresses are caused due to the lack of it. These are the very very important, as you know, this time they're asking a multiple selection type question, so you should know each and every points. Okay, here it will be caused, that means fittings, joints, that may vary over here, right? Then last point is extra conditions like compatibility of displacement are not required to analyze the structure. Here we don't need any kind of like how you solve, like when you will solve the strain energy problem or Castigliano problem or virtual work done problem, right? There we'll need to know what is a displacement, what is a slope angle, or some kind of area movement area method, right? We need this formula. So, but here in this kind of determinant structure, these are not required. But in case of when you will solve a problem, in case of indeterminate structures, you need to include the displacement also. Need to analyze to solve the problem or to solve the support reactions. Now,
And what is the meaning of lack of fit?
lack of fit means like a joining. Okay, so the whatever the joining process or that we will not consider in the determinate structure. Okay, the joining or the it can be of rivet joints, it can be of the whatever type of joints, it is irrespective of that kind of stresses we will not include in this determinate structure. Okay, that is mean by that whatever, if it is not joined properly, we will not consider, we will ignore the joining part. It is joint, we will not see what kind of joints it is. Okay, but in case of indeterminate structure we will look into that if the joints are not proper, that will cause some kind of shear stresses or it will undergo some stresses, right? That will be included in case of your indeterminate structure. Okay, that will be included in your indeterminate structure. It will depends, this both the temperature and this one depends on the problem statement. Okay, both these points will depends on the problem statement, but in case of indeterminate structure we do consider the mode of fitting. Okay, mode of fitting of two members, whether it is a welding or whether it whatever there are a lot many methods of joints, right? So all those things varies in the indeterminate structure, right?
Yes, ma'am.
Okay. Now let's move to the next. Right. Now coming to the core topic of the trusses, how to find out numerically how to analyze these things. Okay, so already I've discussed what are the stresses, and you can see there are a lot many support reactions as I've discussed. The first one which you can see, can you tell me what kind of support reaction it is? The
Hinge,
exactly, it's a hinge one. Second one,
roller,
it is a roller, and the third one,
type of ruler.
it is also a type of roller. So you should know the schematic diagram, that how they represent a roller. Whenever there is some kind of two circular things or single thing, right, that will be acting as a roller, right? So you can understand the difference between, this is the hinged and this is the roller. There is a difference between hinge and the roller, right? Now here, there, I'm just telling you, briefing you the different four different types of trusses. Okay, so the first type is known as a V truss. Okay, it looks something like this, V shaped. Whenever these are the points, you can see these are the joints. These are the joints, right? So this is one member. This is one member connected in a V shaped. So that's why named as a V truss. Okay. Next, this figure, it's like joint like N shaped, right? You can see looks like N, or whenever this kind of structures is called as a N truss. Okay. This one, this kind of structures is known as a N truss. Okay. Shaped like N. Now, when there is a combination of N, V combining and have something like this, right, mostly you can find in your campus, that labs that they are constructed, right? So these are used in the roof mostly. So that's why it is called as a roof truss. That's why it is known as a roof truss. Okay, mostly this kind of structures you can find in your lab. Okay, now K truss, right? It looks somewhat like opposite inverted K shaped, right? You can see inverted K shaped. Okay, so that's why it is known as a K truss, right? Right. Now we will see how to determine the trusses. There are of another three conditions of finding out the trusses. One is, first one is the perfect truss. Okay, or it can also known as efficient one, efficient truss. Now we will say how to determine that those trusses also. The first one is a perfect or efficient. Second one is imperfect, perfect, or it is also known as a deficient. Okay, that is something lacking, deficient. And the third one is redundant, something in excess. Okay, redundant. So first one is a perfect, second is imperfect or deficient, and third one is a redundant. Now efficient one we can find using m equals to 2j minus 3. This is the formula, 2j minus 3. What is this m? M represents the number of members. The number of members. Okay. J represents the number of joints. Okay. Suppose this is the left hand side, this is a right hand side. Okay. So when this both the right hand side and the left hand side becomes equal, then we can say that particular structure, the truss, is perfect. That particular structure is perfect, right? Now let's see an example. um, Let me draw one truss over here. This is one, here, from here another one. These are the joints. Consider this is a simply supported structures. Let's name A, B, C, D, E and F. Right? Now this is a truss. Okay. Now from here, tell me which among this category it will fall. Let's find out that. First, let's find out the number of members. So this is 1, 2, 3, 4, 5, 6, 7, 8. Right? So number of members is 8. Now what is the number of joints? What is the number of joints in this figure?
6.
6. Now let's find out that 2j minus 3, right? So 2 into 6 minus 3. 12 minus 3, how much? It's 9. Right? Now which among is greater? Now which one is greater? M is less than 2j minus 3. Right? Am I right? This one, M is 8 over here. The combination of this 2j minus 3, I got 9. Right? So then I can say when M is less than 2j minus 3, such kind of trusses, I can say it is a deficient or imperfect. Right? This is an example of the trusses which is M when M is less than 2j minus 3. Okay, less than, such kind of thing is known as a deficient. Then if we have M is greater than 2j minus 3. Okay, suppose we have 2j minus 3. For an example, now let me remodule this figure into, like, I am making one more structure here, another structure here. Now I am remodeling this structure into another 2 members. I have included another 2 members. Now what will be the number of members here then?
10.
10. And joint remains same, isn't it? So 2j minus 3. Now 2 into 6 minus 3 becomes 9. So here M becomes greater than 2j minus 3. Now such kind of consideration or such kind of trusses is called as a redundant truss. Redundant truss. Okay. When we have redundant means the name itself you can understand excess, something which is in excess. Right? So when it is greater than, it shows excess, less than, it shows it is less. That means deficient. Okay, using this word, you can also remember that thing. So overall, what you get it? So when m equals to 2j minus 3, we call as perfect. When m is less than 2j minus 3, we call as a deficient. And m is greater than 2j minus 3, we call as a redundant or excess. Right? You should remember this formula also. Okay. Right? Now, while solving this consideration, there are certain assumptions. Okay, there are of certain assumptions. Let me erase this part. Shall I erase this part? Just let me know.
Yes, ma'am.
All right. Okay. Now it is having certain assumptions. Okay. How this trust problems are being proceeded. The first and foremost is all the members are pin joints. Okay, all the members are the pin joints. Pin joints are hinged. That is a you can consider. Second one is whatever the loads are acted only on the joints. Loads are acted on the joints. Okay, so suppose you have one kind of truss like this, right? So it should, suppose they are connected, jointed over here. So load will be, this is one joint, this is one joint, it will act over here. This is an assumption. Again, while solving this assumption, suppose in your problem they have given you over here. They might give you over here, right? So accordingly you need to find out. But these are the basic assumptions that you need to know. Right? If they are giving you the problems, then it is a separate issues. But these are the assumptions. Right? Just okay. The third one, always whenever we solve the truss problem, we consider the truss is perfect. It isn't perfect, that means it should satisfy m equals to 2j minus 3. Okay, this condition. And the fourth one is we should ignore the self weight. Okay, we will ignore or neglect the self weight. We'll ignore or neglect the self weight. These are the four important assumptions. Now there are a lot many different types to solve a problem. So mostly we will try to solve a problem based on the method of joints. Method of joints, and that is very simple method and easy to solve also. Right? Now before solving this method of joints, it having some kind of assumptions. Method of joint means we need to resolve the forces in the joints. Okay, first you need to identify where we have the less number of unknowns. First you need to find out which joint having the less number of unknowns. So first you need to pick that particular joint. After finding that, you need to find out the summation of horizontal forces and summation of vertical forces equate to 0. That is a static equilibrium equation that you need to apply to find out the unknown forces. Okay. Now suppose whatever the unknown forces you have, right? Whatever the unknown forces you have, you should first consider or assume that that particular member, when you're finding, should undergo a tension. That particular member should undergo tension, right? So if when you're solving and you're getting some value, suppose this is a, b, c, d and e, f of AC, you got some minus of 8 kilonewton. For an example, you're getting some value in terms of minus. That means you have initially taken this particular member AC as a tension, and if you're getting minus, that represent it will undergo compression. Right? This is an important assumption that you need to consider whenever you solve a problem. Right? So now we will see or go in deep that how to solve a problem on this methods of joints, because exam mostly you have to use this STEM technique of this method of joints. Okay, so moving to this, before coming to this problem, all right, we will solve this problem. Before that, we'll solve a simple problem before we move to this complicated problem. Okay, so right, let me give you a very simple problem. Now here we have one member called B and A. Here we have another member C. Now both B and C are supported by simply supported beam. Supported by simply supported beam. And distance between B and C are of 5 meter. Okay. The angle subtended between A and B is, they have given the angle. Suppose they have not given the angle, they should give you the height or something else. Okay. Here they have given 60. Here the angle subtended between this BC and CA is 30. Okay. So this is a right angle. 1. And at the point A, they have given 5 kilonewton. They have given 5 kilonewton. Right? Now they ask what are the forces will act on the member and what is their nature. Nature means you have to predict whether there are tension or compression. If it is minus, it is compression. If it is positive, it is a tension. Right? Now these problems, it can be easily solved by your methods of join. Now how to find? Now first of all, you need to find out what are the reactions. First, you need to find the reaction force. So let's consider this is RB and RC. Now how can I write this reaction? What is RB? RB plus RC equals to how much?
5.
Equals to 5 kilonewton. That is very important. 5 kilonewton. Now let's consider this 1. Now I need to find out, before proceeding, I need to find out this reactions. Right? How can I find? Next step. Now what I have done here, I have done the summation of vertical forces equate to 0. I have done this method. Next, which method? There is no horizontal forces. There is no horizontal forces. So it will be ignored. What is the third? statically equilibrium condition. Summation of moments will be 0, equate to 0. Right? So you need to take a moment any one of the points. Now before taking the moments, you should know that what is this distance. Suppose consider this is a point D. So what is the distance between BD or DC distance? You should know before proceeding, isn't it? Now how you're going to find out that this distance? How you're going to find out this distance? How?
Ma'am, AB is also 5.
Which one?
AB and AC.
Not getting. BD is
Ma'am,
also
length of AB and AC.
length of AB and
AB.
AC.
Yes, ma'am.
How it can be same?
Ma'am, I am asking what is the length of AB and AC?
They have not given. They have given the total 5 meter. They have given total 5 meter. Now if I shift this figure into something like this, right? Now this is B. This is A point, which is this way. This is the B point, which is 60, and this is the C point, which is 30. Can I shift this figure? Right? I know the hypotenuse value, that is 5 meter. Can I say in that way? And if I know this angle 60, I can find out what is my AB and what is my AC in fact. Isn't it? It is very easy to find out what is my AB and AC. If I know my AB value, I can know the imaginary points, that what will be, if this is a D point which I am considering, what will be this distance in fact? What is my BD value? Could you get my point? It's a simple
Yes, ma'am.
geometrical formula. Now if I need to find AB, how I'm going to find out?
It's
What
5
is
cos 60.
it is 5
Cos 60.
exactly. So tell me what is the value?
2.5.
2.5. So this is AB is my 2.5. This is 2.5 meter. Now from here, now I will take this triangle. Now I need to consider this triangle. Now again this becomes 90 degree, isn't it? This becomes 90 degree, and now I got my, this is 2.5. Now my this triangle will change something different again. This is D, this is B, this is A. Then again AB I got 2.5 meter. Then I can find out this again.
1.25.
Then 1.25 meter. Then I got, what is my BD? BD is 1.25. So this one is 1.25 meter. Now total is 5 meter minus 1.25 meter. I can find the other end. Now it depends on which side you want to take the moment. If I take the moment about B, right? If you're taking the moment about the B, accordingly you will get it. Now find out the moment. If I take the moment about the point B, then I will get the perpendicular distance of the point A, that is 5 kilonewton, into my BD, which is going in a clockwise direction. I will take as positive. Anti-clockwise direction I will take as negative. So clockwise direction, that is 5 kilonewton into 1.25, right? Positive. Then next we have C point, that is a reaction. It is going in an anti-clockwise direction, that is RC into, what is a perpendicular distance? Tell me. What is the perpendicular
5.
distance? Exactly.
5.
Exactly. 5 equate to 0. Now from here I can find what is my reaction RC, isn't it? Find out and tell me the answer.
1.1.25.
1.25 kilonewton, right? Now if I know the RC value is 1.25, I can find RB, because RB,
3.75.
yes, 3.75 kilonewton. Okay, right? Now I got my this points. So I can erase all and I can finally write down the values of these things. Oh. So I can write here RB equals to 3.75 kilonewton, RC equals to 1.25 kilonewton. Right? Now take the joints at any one of the point where the number of unknown is very less. Now if I look into here, we have three joints. Now if I look either B, A or C, it's going to be the same, right? Any one of the points, it's going to be the same. So I can take any one of the points. So let me consider the point B itself, the joint B itself. Okay. Now in the joint B, what I'm going to do first you need to draw the what are the different loads that are acting at the point B. Now this member always, the BA member always need to consider tensile in nature. So let me consider F of BA. Okay, F of BA, which is positive. This side also I'm gonna take F of BD, which is positive tensile. This one I know, that is 3.75 kilonewton, right? Now this angle I know is 60 degree. Now what I'm going to do is I need to resolve this F of BA. Now if I need to resolve F of BA, I will get one in a cos and one in a sine direction. So F of BA, here I will write what? Cos 60. Here I will write F of BA sine 60. Then another force we have F of BD. Then we have here is 3.75. Now here you need to take summation of horizontal forces equal to 0. The summation of horizontal, if you take, both are unknown. So let me take the summation of vertical first. So if I need to take summation of vertical, what are the vertical forces? Both are upwards. Upward means I need to take positive. Downward means negative. Rightward direction is positive. Leftwards direction is negative. This is a convention I'm gonna follow here. Now all are upward direction. So what I'm gonna take here 3.75 plus F of BA sine 60 degree equal to 0. Right? Now resolve this and tell me what is the answer. F of BA. You will get minus 3.75 by sine 60.
Minus 4.33.
Minus 4.33 kilonewton. That means this is a, what is the nature of BA?
Compressive.
Compressive. Now this kind of question also they might ask, they might not ask you the direct question that what will be the load, what is the amount or the magnitude of force. They might ask the number of compression. So you have to find out each and every members and you have to count down what is the number of compression, number of tensile in nature, and accordingly you have to choose the options. Okay, that kind of questions are also asked, right? So this one isn't compressive in nature, right? Now, if you know F of BA, you can find out the summation of horizontal forces. Now, what will be that? F of this one cos 60 plus again F of BD equal to 0. Now, from here you can find out F of BD.
2.16 tensile.
Yes, 2.16.
16 tensile. Ma'am, 2.16.
2.16. Acha. 2.16. It is positive,
Tensile.
right?
Yes,
Positive.
ma'am.
That means it is in tensile in nature. This is a tensile in nature, right? So you can understand from here. This is BD is tensile. Okay, BD or BC, whatever you take, either of that is going to be same. So BD is tensile and BA is compressive. This is a tensile, this compressive. Now you need to find another unknown members, that is CA. So either you take the joint A or you can take the joint C, right? Find out in a similar way. You can take any one of the joints. You can consider any one of the joints and tell me the answer.
Ma'am, RAC is equal to minus 0.625.
Which one?
RAC.
RAC. Why RAC? Oh, so you are taking R?
AC.
Okay, just a second. Let me check answer. Minus how much?
Minus 0.625.
625. No. Just check your answer. Minus. Again, when you're solving the numericals, do not rush up. Okay.
Ma'am, it's minus 0.625.
Minus 0.625. Let's
Yes,
see.
ma'am.
But here the answer is something different they have given. So let me take at the point C itself. Okay. So at the point C, what I'm getting now, this is the member which I'm going to take again tensile F of CD. Okay, C, D or B, whatever it's going to be said, because here we don't have any joints or connection. Okay, D was just an imaginary point that we consider to find out the distance, perpendicular distance. All right. So either of that is going to be the same. Sorry. F of CA RC. Okay, this one was 30. Now, if I want to resolve this, what will I get? F of CA sine 30, F of CA cos 30. Then again we have another force, F of CD. F of CD and F of BD is same. So we have the value is around
Ma'am,
2.67.
is it 2.5?
I think F of CD value is wrong.
Ma'am, AC value is minus 2.5 and BC is 2.165.
BC is 1.2.1.
Ma'am, 2.165.
2.165. Yes, 2.165. So here we have it is positive 2.165. Here we know, and what is the reaction we have is 1.25, right? Now we can take our main motto is to find out this f of Ca. Now either of the way I can find out. Let me take the summation of horizontal forces. So both are in negative 2.165. Here it is f of Ca cos 30 equal to 0. Now f of Ca, what I'm going to find is 2.165 minus of by cos 30. Now what is the value you're getting here? Please tell.
Ma'am, minus 2.5.
Minus 2.5 kilonewton. This is the answer. Okay. So minus 2.5 means again it is a compressive. So here again we have a compressive. So I can say the nature of the member. Here we have two compressive members and one tension members. Okay. So this kind of question also may ask, but for that you need to solve this entire thing. Okay. You need to solve this entire thing. All right. Now this is a method, and now we will solve another problem. Let's solve this problem. Let's solve this problem. Okay. I'm giving you 3 minutes time. Read the question. All the members in the given truss are elastic with Young's modulus 200 gigapascal, have identical cross section with a moment of inertia has been given 0.1 centimeter power 4. The lowest value of all the load T are with the truss fails due to the buckling is. And here they have given round off to nearest integers. So could you able to find out, or should I solve? Yes, first you need to find out. Okay, first you need to find out the reaction. Same. See, this is first of all. Let me tell you. Gate exam. Try to understand. This is a 2 mark question. That means always gate. They're asking 2 marks means you have to use two formula. Okay. Now here they have given in this question the Young's modulus. Right? They have given you. Just a second. They have given you the Young's modulus. They have given the I value, that is moment of inertia. Okay, careful with the units. Okay, next thing they have asked the lowest value of P at which the truss fails due to buckle. Now, already in the previous session, we have already crossed through the buckle, right? You remember we have found out. So buckle, what was that formula based on this Euler's equation? P critical equals to pi
Pi
square
square EI by LE square.
E by L square. Very good. Okay. Now this is the formula. Now our main here is we need to find out this P value. We need to substitute over here. That is PCR value. Okay. Sorry, we need to substitute here when we resolve this into this formula. Whatever the value of P we will get, and that is the truss fails due to buckle, right? That's what they ask over here. So first of all, you have to proceed with the same thing. You need to find out the reaction forces. Now here in this problem statement, what are the forces in B? It is a hinged, and the C we have the roller. So first of all, here we will have one vertical force. Let's consider R of B. Horizontal force, let me consider H. Okay, you can denote anything. Now again the C point we have the roller, that means there will be a displacement about the X direction, but Y there is no displacement, so let me consider RC. Alright, now from here I can write RB plus RC equals to P. Can I write? Now take the moment at any one of the direction. Now H will be 0 because we don't have any horizontal displacements anywhere, right? It will be simply get to 0. Now what you have to do? The summation of moments. Summation of moments. Now summation of moments, you can find either of the reactions. Okay, so when you find again the same method, they have given the angle over here. The AC distance has been given 10 centimeter. All right. Now I hope you have found out this value, BD distance. So let me find out that value from your chat box. You got 98 value. Tell me the distance
Five,
between
5 centimeters.
5, right? You got 5. So this one is 5 centimeter, right? Now when you find out this moment, how you're going to find out this? That means let's consider at the moment at the point B, you're considering. So P, the clockwise direction, P to the point A, it's going clockwise. P into 5. Then you have RC to the point B, it's going to be in anti-clockwise direction. RC into 10 equal to 0. Now what is the value of RC? P by 2, I think. Isn't it?
Yes, ma'am.
You'll be getting P by 2. Now if the RC value is P by 2. Then what will be the RB value is also P by 2. Right? Now everything got in terms of P by 2. Now your main motto is to find out this P value. Right? Your main motto is to find out this P value. Now find out the P value and tell me. To find out this P value, main motto, you need to find out this P value. So first you need to find out the point joint. Which joint will you find first? So which joint will you find first?
Ma'am, should I tell all the forces RAB, RBC, and RAC?
Okay, tell me. No, first of all, which joint will you take? Your
Ma'am,
main
I took point B.
point B. Okay, you can take either point B or C. Okay, first process is that either you can take point B or C. Now, after finding point B, what you have done?
Ma'am, RAB is equal to minus P by 2 root 2.
Which one?
RAB value.
R A B value is how much?
Minus P by root 2.
P by root 2.
Yes, ma'am.
Okay, P by root 2.
Ma'am, it's negative. It's in negative.
It's a negative. All right. Okay.
And ma'am, RBC value is minus P by 2.
R B C is
Minus P by 2.
P
Sorry, P by 2. P by 2.
plus P by 2.
Yes, ma'am.
Right? Now, what is the next procedure? You got your this points using the joint B. Next, what is your next thing?
Ma'am, at point C, I got RAC is minus P by root 2.
Hmm?
Ma'am, RAC value.
R AC value is
Minus P by root 2.
minus P by root 2. Okay, that is at the point C, right? Okay, now what is the next procedure? How will you proceed further?
After that, I don't know, ma'am.
Right. Now here, read the question. The lowest value of the P at which the truss fails due to buckle. Okay. Lowest. Now, both the AB and AC, right? Both the AB and AC, you have the same. That is P by minus P by root 2. Here also RAC, you have minus P by root 2. So you can take any one of the side, either by this way or this way. Now first you need to find, let's consider you are considering the AB side. You are considering the AB side. Now from here you need to find out what is the length of AB. What is the length of AB? How will you find this length of
7.07.
7.0? So how you are finding this length?
Ma'am, we right angle triangle.
Yes,
So
right.
AB will become 10 cos 45.
Okay, sine 45. Why 10? Why 10 you're taking? Okay, yeah, either of that. So let me check the answer. Just a second. Hmm. You got 7.07, right?
Yes, ma'am.
Yes, 7.07. It is in centimeter. So length you got is 7.07 centimeter, right? Now, so you're taking any one of the beam, either AB or BC. Length is known, so you can take any one of it. So let's consider this is the critical load. That is P by root 2. Let's ignore the magnitude. That is just consider the magnitude. Okay, equals to pi square. What is the E? 200 into 10 power 9. Okay, into I 0.1 centimeter they have given. So you have to multiply to into meter means power 4, isn't it? Okay, by L. L again you have L square 7.07 into 10 power minus 2 whole power square, right? Now this root 2 will move.
Ma'am, why we take L is equal to 7.07?
L equals to,
7.07.
you need to find out this, no? You only said 7.07 is coming. What is
Ma'am,
this L?
L,
Take
ma'am,
this any
LE
one of the
value,
triangle. Huh?
ma'am, LE values we take na कि one end is fixed and one is roller end.
No, no. Here they have not said any other conditions. So if you change the condition, this is hinge, this is roller. We don't have that system in the column. Okay, buckling, we don't have that conditions. Our main motto here to find out the L. This length of this beam alone or this column. Okay, we cannot use the end conditions. Here they have not mentioned the end. They have only said that this condition is going to buckle. And both the side we have two different conditions. What condition they have said? They said the lowest value of P. They have not said that the conditions. Whenever the side we have this condition, we will take that. So we will not take into the consideration. You got my point?
Yes, ma'am.
All right. So you have to understand if both the sides having in your column we have four conditions, right? Both the end hinged, right? Both one end fixed, one end hinged, then one end fixed, one end free, and both the end are fixed. These are the four conditions, end conditions we have in the column. So here we cannot consider this as a column. In fact, they have just said this truss is going to fail due to buckle. So we are going to use the Euler's equation alone. Could you able to follow? So understand whenever you are implementing some conditions, try to understand the what they have, whether they have mentioned it's a column or anything else. Okay, right? So find out, solve this thing and find out. See what they have asked: round off to 4 kilonewton and round off to nearest integers. So you have to type accordingly. So solve this problem and tell me the answer. You can write down in a chat box if you have solved.
Ma'am, is it 39?
How much? 3?
No, ma'am, sorry, ma'am. Ma'am, is it 558?
Yes. Nearest to that answer. Okay. The answer ranges in between that. Okay, when you solve that, 558. Okay, kilonewton. Right? So you can expect such kind of problems. There are a lot of different types of problems they're asking. So this is one of the problem, right? So they have asked what will be they have precisely asked only for PQ and QR. Okay. So you have to answer and R respectively. So you cannot exchange that values. Okay. See the option B and D. So they have just interchanged. So do not get confused and choose the option correctly. Okay. So this is another different kind of problems. They might ask this kind of problem also. This is another type of problem. They have asked what is a magnitude only about SR. So precisely they have asked one of the members here. Okay. So such kind of problems can also be expected. Now, mostly you will be having this kind of problems. They won't ask such huge, large of trust problem, right? So you can expect, but methods are going to be the same. Okay. Now coming to the next agenda is that in general for the trusses, how to find out the whether that beam, okay, is stable or statically unstable. That means statically indeterminate or unstable. Okay, so there is another way to find out. So not only that, there is also way to find out the degree of static indeterminacy of the system or the structure, right? So sometimes they also ask this kind of questions. So degree of static indeterminacy of the system. So there are four formulas you can see, three formulas. So we will see what are these things. Now B represents the number of members or the number of bars that we have in any section. N represents the number of joints. Okay, n represents the number of joints, and this formula has been derived from the same thing what we have seen. M equals to 2j minus 3. Okay, so what is m? Number of members. So I'm just compilingly taking this term in the left hand side. So m minus 2j minus 3 equal to 0, and this condition satisfies when it is the structure or the any members are completely perfect. Okay, now when it is indeterminate, same as we see either indeterminate or imperfect, we have two types. One is a deficient, one is a redundant. When m is less than 2j minus 3, we call as a deficient. When m is greater than 2j minus 3, we call as a redundant. Parameters. Okay, the degree, what is the degree of F defines the degree of statically indeterminacy of the structure. So we will see few of the examples here. Okay, now let's find for the first one. First one, static indeterminacy of the structures. First one, tell me what kind of thing is it is. So note down this formulas.
Determinate. Statically determinate.
Statically determinant. How you are
Determinate.
telling? What is the number of beam
Number
you have?
of bars is 5.
5. 1, 2,
joints are
3, 4, 5. Right. And number of joints, that is
4.
n, is here 1, 2, 3, and 4. Right. So what
Yes,
was the
ma'am.
formula? 5 minus 2 into n,
2
right?
into 4 minus 3.
2 into so 5 minus 5, it comes to be 0, right? So 0 means it is statically determinate structures. Okay. Next member, B member. What is a B? What is N?
6 bars
6 bars,
and 4 joints.
4 joints. Now
Yes.
6 minus 8 minus 3. What is that?
Indeterminate.
6 minus 5, which is what we are getting, plus 1, right? Am I
Yes,
right?
ma'am. Yes, ma'am.
So plus 1 means greater than 0. Which is greater than 0 here? This is greater than 0. Sorry, this is greater than 0. Right? So greater than 0 means what? It is
Indeterminate.
indeterminate. Okay. Similarly, you can find the other structures. The same thing happens for the beam and frames. So beam, in the question, if they're giving you the truss or the beam and frames, we have to read the question carefully. Okay. So suppose they have given the truss, so you have to use the previous formula. And if they are giving in the question as a frame, so frame, there will be three support reactions. One is a vertical, horizontal, and the movement. Okay. So on that cases, you have to use this formula to find out about the structure. Okay. Here also B represents the number of members or the bars. N represents the number of joints. R represent number of support reaction. So you need to count the number of support reactions. Okay. And K is an additional conditions, that is if there are any hinge. So whatever the value you will get, that is F value, that is your the degree of static indeterminacy about the any structure. Okay, so remember this formula and note down this formula. We will look into some of the exercises. So they might ask you 1 or 2 marks from this kind of topic. And this is also an equally very important topic. So let me write out the formula over here. F equals to 3B plus R minus 3N plus K. This is the formula. B represents the number of members of the bar, R represent number of support reaction, N represent number of joints, and K represents the number of the additional conditions. Okay. Now let's find for this. So already I have given the solution for this thing. For the first one, here you can see. So they have given it, they have mentioned it is as a frame. They have mentioned U as a frame. Now for the frame, you have to use this formula. Okay. Now what is the number of B for the first one? 1, 2, 3. 3, you have the 3 bars or the members. Next I have the reaction. Right. Now here, what kind of reaction it is? What kind of support reaction is that?
Fixed.
It is fixed. So in the fixed, we know we have one vertical, one horizontal, and one will be the movement. So both the end are, we have our fixed. So here 3, here 3. So R becomes 3 plus 3 become 6, right? Then N is a number of joints. So what is the number of joints here? 1, 2, 3, and 4. 4 joints. And what is a K? There is no additional or any other hinge supports, right? In between, if there are any hinge supports, you have seen in the first slide itself, I have discussed that if there is any hinge support in between, so in that kind of consideration, okay. So here we don't have any sort of additional hinge over here. So it will be considered to be as a 0, right? So here you can see in the second and the third one, here we have additional hinge over here. So in this kind of consideration, the K value will be changing. So simply find out the value, substitute the value over here. So we have 3 into 3, 9 plus 6 minus 3 into 4, 12 plus 0. What is the value we get? 15 minus 12, right? So here the 3 is the degree of statically indeterminacy of this particular frame. Okay? Right? Next, let's find for the second one also. Second one, what is the number of members? 1, 2, 3. 3 is the number of members of the bar. Now, what are the number of support reaction here? Number of support reaction. Tell me. What will be the number of support reaction over here?
Ma'am, it's written 5, but I'm not getting how it's coming 5 because
It is written
if we
5.
look, ma'am, if we look at from left side, ma'am, it is fixed. So we get three support reactions.
Hmm.
But at right side, I am getting this as a roller side.
Okay. See, that's why I'm solving this. See, here we'll have vertical, one horizontal, and one movement. Right? Here also we will have one vertical, one horizontal. Due to this fixed, we'll have one movement. Due to this ruler, this is also sorry, this is also another hinge, isn't it? So what will happen when there is a combination? Please make a note of this thing. When there is a combination of fixed and hinge altogether, both will counteract. Both will counteract. So what will happen? There will be both this movement in one direction, another direction due to the movement, due to this hinge will nullify, will get nullified. Okay. So if this thing get nullified, 1, 2, 3, 4, 5. What is the number of support reaction? We have 5. Please remember this is another important concept. When there is a fixed and there is a hinge in between, this will get nullified. Okay. Next, what is the number of joints? What will be the number of joints? 1,
4.
2, 3, 4. Yes, 4. Then what we have? K. Now what is a K? K, remember the additional if there are any additional hinges. Now here, what are the additional hinges you can see? Here one hinges you can see, right? Here another hinges you can see, right? This is the hinge along with the support. So we have considered that. Okay. So we have two additional hinges. So K becomes 2. Now substitute in that is 3 into B is 9 plus R is 5 minus 3 into N 12 plus 2. Substitute and tell me 14 minus 4. Sorry, another 14. Are you getting 0?
Yes, ma'am.
This, the degree of static indeterminacy of the frames are 0. Okay. So this kind of questions also they might ask you, right? There are a lot many different types. Okay. You have to use the same principle to find out, and equally they can ask you for the beam. Both for the beam as well as for the frames, they can ask you, right? Equally they can ask you the support reaction. Suppose same as you have how you have found out that same, they can ask you to find out for this particular thing what will be the support reaction for the point A, or what will be the support reactions for the point B. They can also ask you like this kind of questions. Okay. So it's almost time we have. So upcoming session, we will start with a vibration. Okay. So this kind of questions you can expect, you can take as an assignment. This kind of questions you can solve, and if you have any difficulty you can ask me.
Ma'am, hello.
Yes, please.
Ma'am, at A and B, we can consider that additional hinges, ma'am.
A and B,
Here,
which one?
here, it's round.
No. They have given rounds, but it is here you need to find out only the reaction, support reaction.
Hmm.
Okay. So
Okay.
they will be mentioned over there. Suppose they're asking you to find out degree of uh, sorry, degree of indeterminacy, right? In that case you have to find. Here they have not mentioned. Okay.
Okay.
So here
If they mentioned, we can consider it, ma'am.
yeah, if see, you should know the two different types. Okay, that is a different type. There you only need to find out the degree of indeterminacy. Okay, this is this kind of question. Okay, what they will ask you, they will ask you to find out the support reaction alone. Okay, here they will ask you only about the support reaction. They are not going to find out or ask you to find out what is the degree of indeterminacy. Okay, here you just only need to resolve the summation of vertical forces, summation of horizontal forces, and summation of moments. You need to first resolve this force. So when you resolve, you will get one in this direction, another in this direction. You need to take the moment, and you will find out the other parameters. Okay. So since it is a hinged, you will have the R of A vertical, one will be in horizontal direction, R of A horizontal. This is a roller, only will have one direction, R of B, right? So when you resolve this, you will know what is a P value. So summation of horizontal force, we can write here whatever the horizontal force we will get here. This one combinedly with the RAH equal to 0. You can find out the parameter of RAH. Then summation of vertical forces you can find, that is RAV plus RB. Okay, minus of whatever the value this component will you get, that value equate to 0. right? To find out those parameters in terms of P, you need to take the moment where the highest amount of forces are there. Usually we take the moment about that point. Here we have at the point A. So you can take at the point A moment about the point A. You can find out the one of the unknown parameters, substitute over there, and you will get the support reactions. Okay, it's a very simple problem, very simple problem. Okay, so here when you solve this thing, you will get P on both the sides. You will get P because when you resolve cos of sine will also 1 by root of 2 root 2. So root 2 will get cancelled off. You will get both the side P. Here also will get P, right? So overall you will get R of AV plus RB equals to P. Here you will get R of AH equals to minus of P, right? So you need to find out either of RB or RAV. So you take the moment about the point A. So if you take the moment, so RB into what is a perpendicular distance is 2A. It's anti-clockwise direction, negative. Then along the point, this direction, C point, 1 will be is coming to 0. Here we have this. Again, clockwise direction, positive. P into perpendicular distance is 2A, equate to 0. So from here I can write RB equals to P. I can write. Now if RB equals to P, then RAV equals plus RP plus P. If this will get cancelled off, then RAV will becomes 0. Right? This is what the answer you got from this solution. Right? Could you follow? Any other doubt? Any other questions? You can ask me.
Ma'am, that question of shear center.
Sorry, I didn't get it. Question of?
Shear center, ma'am.
Okay. Question of the shear center. Yes, I got that answer. I will today now itself. I will forward that. Okay. I will write down in the solution and I will write down a paper and I will share with you.
Ma'am, could you please explain that solution?
Solution, it says that already I've discussed that with you guys, right? That how they are solving. And when you make the ratios, okay, okay, what I will do is now I'm having a shortage of time. How about next class? Very next class, I will be solving that question at very first, and then I will proceed to the next. Okay.
Yes, ma'am, it will be really great.
Okay.
And ma'am, what about the space dynamics class?
Flight dynamics, I have already asked the sir,
Ma'am,
teacher.
space dynamics.
Acha, space dynamics.
Yes, ma'am.